Textbooks out, open to page 98. Let's see how you did on your homework. Practicing with some of the different properties of algebra. We talked about 3 properties in our last lesson. If you're watching on YouTube, it may have been yesterday. For these students, it's been a long weekend. They just came from an exam. Their brains are fried, but let's see what we remember. We had one property that said we could flip-flop stuff, move stuff around, and it wouldn't really affect the answer. There's only 2 processes you can do that with, though. What 2 processes can you move stuff around and it ain't going to mess up the answer, Michael? Addition and multiplication. You can change the order of addends, you can change the order of factors. The answer is unaffected. We're going to see how we can use that to our benefit today. What property is that, Evie? The commutative property. We had another property that said that if there's things grouped together, you could change what is grouped and it wouldn't change the answer. But again, only 2 processes. Can you change up groupings, Aubrey? Well, which 2 processes can you change the order without messing stuff up? Once again, it's addition and multiplication. The groupings can change and it's not going to mess stuff up. And you said that's called the associative property. And there was another property that said that if you had a particular value outside some grouping, you could multiply that value by every single number in the grouping and it wouldn't change the answer. But what were the only 2 processes that could be inside the grouping and it wouldn't mess it up? Hayden? Addition and subtraction in the grouping. If there was a multiplication or division in that grouping, it would mess things up. But if it's only addition and subtraction, you could multiply that value by everything in the parentheses. We wouldn't want to leave anyone out when we multiply that number. What's that process called, Glenn? Distributing or distribution, the distributive property. A few ways we could say that. That said, let's take a look now at the homework where we practiced with these different properties. Pages 98 to 99, the homework numbers 1 through 24. And it looks like you did those last 3 on paper. Yep. All right, excelente. Bueno. C. Come back to you. Oh, there, we got it. All right. Bueno, yeah. Okay, let's take a look. Number 1, what number is missing and what property is being used? Maybe we should take that the other order. Maybe see what property are they trying to use, and then that'll tell us what number we should put there. Number 1, what property, Danielle? Appears they're using the distributive property, so obviously what needs to be multiplied by the 7? The 3, just as it's multiplied by that minus 5. Number 2, what property they're trying to use here, Michael? The commutative property. So what number should go in the blank? 671. 671. Number 3, what property are they trying to use, Hayden? The associative property. And what number should go in that blank? 3. Number 4, what property, Aubrey? Commutative. And what number in the blank? 6. Good. Commutative property. Put a 6 in there. Number 5, Evie. 2, because they're using the associative property of multiplication. And number 6, go ahead. Well, they're not rearranging anything. Do you see how the 3 was at the beginning and it's still at the beginning? The 2's at the end, it's still at the end. So obviously the missing number would have to still be 5. So they're not changing the order, which would be commutative, but they are changing what's grouped, which would be associative property. Good. Number 7, we were using the associative property to rewrite 6 times 11 times 4. How did you rewrite it, Danielle?
6 times, and then in the parentheses, 11 times 4.
Good. 6 times the quantity, 11 times 4. Number 8, how would we rewrite that using the commutative property, Michael? 3 times 9 is correct. How about number 9, Hayden, rewriting using the distributive property?
7 times 5 minus 7 times 4.
Good, and I'll be honest, I mean, in that particular problem, it's not easier distributing, right? It'd be easier to do 5 minus 4 is 1, and 7 times 1 is 7. But, you know, they could use the distributive property, I guess is the point. Numbers 10 through 12, any questions, first of all, 1 through 9? Any questions? How many got all the 1 through 9 correct? All right, let's take a look at 10 through 21 now. You're supposed to identify, is that a true or false statement? Is that equal or not equal? So writing either equal sign or a not equal sign. And then if there was a property used, identifying which property was used. Of course, if they're not equal, Obviously, no property was accurately used. They would have you write no property. Number 10, what do we put in the blank, Aubrey? Equal. 35 equals 35. What property was used? Commutative. Number 11, what do we put in the blank, Evie? 16 minus 4 would be 12, but 4 minus 16 would be negative 12. So we should have a not equal. Oh, so number 11, what property were they pretending to use? Commutative, but you do commutative property with subtraction, so should have a not equal to. Number 12, Evie. Equal, good. You do 15 equals 15. What property were they using? Distributive. Number 13, Glenn. What goes in the blank? Let's see, 88 times 2 is 176, and 11 times 16 is also 176. So we should have had an equal sign. What property is being used that should show us, yes, it will be equal? Associative property. And since it's multiplication, associative property would work. Number 14, back to Glenn for redemption. Equal. We've got 14 equal to 14. What property is being used? They're not changing any orders, they're just changing the grouping. Associative property of addition. Number 15, Hayden. What property are they trying to use? But did they use it properly? No, you can't use associative property on subtraction. You end up with 2 is supposedly equal to 18, and that's not true. Number 16, Danielle. What property did they try to use? Did they use it properly? Yes, they did. They are equal to each other. 45 equals 45. Number 17, what property did they try to use, Aubrey? I'm not even sure what they were trying to do, to be honest with you. That's not even close. 490 does not equal 55. So I don't even know what property they're pretending to use. Kind of a distributive, maybe thing. I don't know. That's just weird. Number 18, what property are they trying to use here, Michael? Associative. Did they use it well?
Yeah.
Yes, they did. 18 equals 18. Number 19, Evie, what are they trying to use here? Distributive. Did they use it right?
Yes.
I'm getting 90 is supposedly equal to 450. So no, because remember, it's only addition, subtraction you can use distributive and not multiplication. Number 20, what property are they trying to use here, Glenn? Did they use it right? Yes, they did. Flip-flop the addition, still get 13 equals 13. Commutative property works. Number 21, Aubrey, what property are they trying to use? Associative. Did they do it right? No, 3 does not equal 12, because again, you can't do associative on division, only addition, multiplication. So basically, all of the evens were good, and only one of the odds was good. Only number 13 was good. Otherwise, all the odds were wrong and all the evens were right. How many got all of those on 10 through 21? Anyone perfect? Wow, a couple of you. Anyone just missed 1? Just missed 2? Any questions on the one or ones we missed? Yes, ma'am. 19. Number 19. Again, it looks like distribution, right? 5 times the 6, 5 times the 3. But if you do that, you have 5 times 18, which is 90, right, is supposedly equal to 30 times 15, which is 450. That's not true because you can't distribute into a multiplication. You can only distribute into an addition or subtraction. Or we could say you distribute into sums and differences. All right, good. Any other questions on those? All right, number 22, order of operations. Quick review here. In order of operations, what's the first thing we always try to simplify, class? I heard it, grouping symbols, parentheses being the main one. And here we do have a little set of parentheses, Glenn. 4 times 2 becomes a 2. The next thing we would check for normally, class, would be exponents, but there aren't any exponents here. So then the next thing we would have to take care of would be good, multiplication and division. I see a multiplication, then another multiplication, then a division, and we're just going to go straight across in order as they come. 2 times 5 times 2 divided by 4, 5. So that entire string of stuff becomes a 5. And then we just add to get, class. 19, our answer on number 22. How many had 19? Good, perfect in here. All right, looking at number 23, I got a 6 times 8 minus 32 divided by 8 minus 4 squared minus 1. And what do we need to do first here, Danielle?
You do the parentheses with the 8 minus 4 because it has an exponent. And
Well, not because it has an exponent, but because it's parentheses. And 8 minus 4 is? 4. So we just do the subtraction. Now what's the next thing we would do, Michael? The exponent. And 4 squared is 16. Good, not 8. Remember, it's 4 times 4, which is 16. So let me go ahead and rewrite what we've got here. All right. Then what do we need to do, Hayden?
Multiplication and division.
Multiplication and division. Here's a multiplication, here's a division. They're not connected, so I could do them at the same time. I got a 6 times 8. 48. And I've also got a 32 divided by 16. 2. And now we're able to just go straight in order. 48 minus 2,
46.
minus 1, 45 should be our answer. How many had that for number 23? All right, questions on that one? And looking at the last one, we do have a grouping symbol. What is our grouping symbol, Aubrey?
The bar.
The fraction bar, good. And so everything above, we could put parentheses around it. Everything below, we could put parentheses around it. The fraction bar essentially does that. But within the grouping, I've got an addition, a multiplication, and an exponent. Which of those within the grouping comes first? The exponent. 2 cubed becomes 8. And then I've got 2 remaining processes. I've got addition, multiplication. Which of those comes first? The multiplication, 3 times 8 becomes 24. And then finally, I could do my addition, 4 plus 24. 28. So my numerator becomes 28. That grouping is done. In the denominator, how should we handle this, Evie?
The division first.
Good. Since they're both multiplication and division, they're the same steps. We just go in order. 4 divided by 2 times 2. 4, so our denominator becomes a 4, and then we do one more class division. Now that we've got a single number in the top, single number in the bottom, now we divide to get 7 for our answer. How many had 7 on number 24? Questions on number 24? All right, any questions at all on the homework? All right, I want to talk about a little bit, it's called a level up. We've done a couple of these in this class, and level up is stuff that isn't typically tested. It may be in some instances, but just stuff to try to help you become more efficient, or in some cases to preview things that are coming up. One of the things I want to show you here today are some shortcuts we can use to make life easier, because mathematicians are lazy. And so one of those things is the commutative property of addition, and I kind of referenced this in the last lesson, allows you to add out of order. Multiplication is commutative. You can multiply out of order and try to strategically multiply or strategically add numbers that just go well together. One example I gave you is when I was in elementary school, starting that early, I would try to find within like the columns of numbers on those really massive addition problems, any 10s I could put together, 8s and 2s, 7s and 3s, stuff like that. We could do a similar thing here. Look at the first blue box on page 99. They give you the problem of 52 plus 37 plus 48 plus 3. Now I see that the 37 and the 3 could easily add class to get 40. And then the 52 and 48, realize 52 is 2 above 50, 48 is 2 below 50. Well, that kind of cancels out, right? If you added 50 and 50, you get 100. So 52 and 48 would also add to get 100. So we've got a 40 from those two numbers. We have 100 from the other numbers, and 100 plus 40 is 140. And we were able to do the whole thing in our head instead of, let's see, 2 plus 7 is 9, plus 8 is 17, plus 3 is 20, right? The 0 carried the 2. 2 plus 5 is 7, plus 3 is 10, plus 4 is 14, 1, 4, 140. Could we do that? I guess. Maybe sometimes a little bit easier way. Multiplication, though, is really going to be beneficial to you, especially when there's fractions or decimals involved. Look at the problem there in the next blue shaded box. 5/7 times 8 times 14. I do not want to take 5/7 of 8. 47ths is ghastly, right? But that denominator, 5/7, right, can cancel with any numerators, the way that I like to teach it. This is the way I show it when we get a little bit older. So if I think of this 8 as an 8 over 1 and the 14 over 1, the 7 can cancel with any of these numerators, and I want it, obviously, class to cancel with the 14 to get a 2. And, of course, a 1 down here. Now I'm also going to do 5 times 2 is, because that's easier than 2 times 8, right? Or even 5 times 8. 5 times 2 is 10, times 8 is 80. And that way we're working with times tables we already know, right? We know 10 times 8. Now we do know, I don't know that 40 times 2 is that hard, right? But still, look at the next one. 0.25 times 7 times 4. Well, if you know that 0.25 means 1/4, A fourth of 7 or a fourth of 4?
4.
A fourth of 4 is
1.
1. Times the 7 that's left is
7.
7. Do you see how going a little out of order can speed up your work? How many say, I already go out of order, I figured this out? How many say, I've never thought of this before? All right, does it make sense to you? Maybe by the end it will if it doesn't now. Now sometimes, look at that next one. 0.37 is not easy to multiply by anything. So I always save the decimal for last. Because I know 6 times 12, right?
72.
Do the part you know, and then when you can't put it off any longer, get around to the ghastly looking decimal, right? As opposed to 0.37 times 12, which is ghastly, and it'll give you a ghastly answer, which then you have to multiply by 6. That's lots of ghastly. Let's just ghastly at once. 7 times, I love that word. 7 times 2?
14.
And 7 times 7 plus 1?
50.
And put the 0. 3 times 2?
6.
And 3 times 7?
100.
And there's nothing to carry there. Oh, that's 6, not 7. And 2 decimal places, 26.64 look right? Yes. All right, questions on that? Makes sense? Going out of order on the multiplication. Now, this next one's a little bit deeper, okay? But maybe it'll be helpful to you. Look at the last blue box. 4 times 375. If I rewrote this 375, that's a 7, just a horrible looking 7, as 400 minus 25, I could multiply 4 times 400, 1600, and 4 times minus 25 to get minus 100 to get 1500. This is useful when numbers are really close to hundreds and things. For instance, if I had, 7 times 503. Well, this is 503. What's 7 times 500? Well, 7 times 5, 35. Tack on the 2 zeros, right? And then 7 times 3, 21. So 3, 5, 2, 1. Maybe just a little bit quicker and easier. Maybe, maybe we could make the argument it's really not that much faster. But from doing mental math, right? For instance, you're in the store, you're trying to do some shopping or whatever. You're like, I can't be pulling out a calculator. I'm certainly not pulling out paper and pencil and writing this down. So trying to do mental math in your head, that's really more what this is beneficial for. Turn the page and look at some yellow example problems in the yellow shaded box. They want us to simplify each problem. Now again, normally I do this in my head. I don't normally write this out, but they've got an 8 times 7 times 32. Which number do we want to take 1/8 of? Remembering that of means multiply class. 32, an 1/8 of 32 is 4. And then you multiply the 4 times the 7 you ain't used yet.
28.
28. Makes sense? Now, they take the time to rewrite the 1/8 times the 32 times the 7. Again, I don't normally take the time to rewrite that in order per se. I just kind of mentally know which numbers I've used, which ones I haven't. Look at the next one. 3.14 times 25 times 4. Well, if instead of grouping the 3.14 times 25, which is ghastly, if instead we group the 25 times 4 to get 100, and then when you multiply by 100, remember, you just move the decimal 2 places, right? And there's your 314. Makes sense? There's another example of the big number, 7 times 312. Well, again, think of it as 312. Well, what's 7 times 300?
2100.
2100, and of course the 7 times 12?
84.
2100 plus 84 is 2184, 2184, and there's our answer. Do you see how all of those could easily be done in your head, which is kind of the point of the whole thing? Questions on that? Hands down. All right, let's go ahead and take a look at the next page then, page 102. Flip over to page 102. All right, so number 1, it's got a 4th times 3 times 12. They want you to rewrite it 1/4 times 12 times 3, so fill in the blank. Go ahead and take a 4th of the 12 to get times the 3 gives 9. Did you see how to fill in those blanks? All right, look at the next one. They've got a 4 times 7 times 5 times 3. I think the easiest multiplication would be the 4 times 5 times 3 times 7, because 4 times 5 gives you an easy number, 20, and then the 3 times 7 also gives you an easy number, 21. Do the multiplications you know. Then you only have one hard multiplication, but really, if you remember that 20 is you multiply the 2 and stick a 0 on at the end, you get 42 with a 0 at the end, 420. Right? Questions on that? Again, I love multiplying numbers that end in 0 because you don't have to worry about the 0 till the end, just stick it on. Look at the next one. They got 0.125. That's just ugly. But what is 0.125? 1/8 Oh, so what number should we put right next to the 0.125?
8.
8, because an eighth of 8 is
1.
1. And that means that the 5 times the
6.
6 at the end should give us a
30.
30. So 1 times 30 is
30.
30. Again, rearranging the problem just makes our life easier. 4 times 196. Okay, this is legitimately easier this way. If you rewrite the 196 as 4 times, and then it's 200 minus 4. So you could distribute to get
4 times 200.
4 times 200, and you could do minus
4 times 4.
4 times 4. Of course, 4 times 200, class.
800.
800, and the 4 times 4 is the
16.
16 that you see there. And now we're just subtracting a 16 from an 800.
784.
784, if you're good with your borrowing. Do we follow that one? That one's probably the least intuitive for most people. That's like next level, hence they call this level up. All right? But that's what separates the quick from the the fast from the not as fast. All right, number 5. They got a 1,992 plus 459. Now here's where I like to change things up a little. 1,992 is so close to what really easy number? 2,000. How far away are we?
8.
We're only 8 away. So let's steal 8 from that 459 and kind of think of it as a 451 plus 8. But then let's add the 1,192 plus the 8 to go ahead and get our 2,000 plus that leftover 451. Does that make sense what they're doing there? And now we can do 2,000 plus 451 in our head.
2,451.
2,451. Again, normally I don't think of all those numbers written out, but just kind of like if I see this problem, I'm like, okay, steal 8, and that's 2,451. I could do that in my head. That's normally how I do it. I wouldn't write all those numbers out, but technically I guess that's the mental process going through my head. The next one's awful looking. 1/4 times 6.28 times 5 squared times 16. Well, for starters, which of those can we take a fourth of really easily?
16.
So let's put the 16 after the 1/4, and that means that the 5 squared, which we could do in our head to get 25 can go in the final blank. We'll go ahead and take the fourth of 16 to get 4, and we still have, of course, our 25. But I don't want to multiply that 6.28 till the very end, right? But I can easily do
4 times 25.
4 times 25 to get 100. And 100 times 6.28 is easy.
6 times 28.
628, just move the decimal twice. Do you follow the progression question?
Is it 6.28 the square root or the...
That's approximately 2 pi.
Yeah.
Yep.
What?
Well, 3.14 is pi, so 6.28 is approximately 2 pi, which, of course, you remember from all your geometry formulas last year, right? 2 pi rh plus 2 pi r squared, surface area of a cylinder, and 2 pi r circumference of a circle, all that stuff. Yeah, all that stuff is a coming. And I will say this kind of stuff, rearranging, can make those volume and area problems so much easier if you can find the easiest way to do all your multiplications. So that's one of the reasons we're spending some time talking about it. All right, so they kind of guided you through 1 through 6. I want to see how you do on 7 through 12. I want you to kind of figure the easy way to do everything. Do as much as you can mentally. Here's where I'd be really impressed if you could just write the answer to it all in your head, okay? But if you need to write some stuff down, that's okay too. Do 7 through 12. They're on page 102. And again, quizzes and tests, if you need to show work, that's fine. If you have to do it the long way, that's fine. But I love to be fast and accurate. Accurate's the most important, but fast is pretty awesome because, lazy. Don't want to spend all day doing math homework. So try to spend a little time here on this Monday morning, speeding up your brain by teaching it shortcuts. Love shortcuts. Glenn's got them all figured out. No, Evan, he's not using a calculator. Evie's done. Hayden's done. Again, are there bonus points on quizzes and tests for finishing first? No, but it is a pretty cool feeling. Unless, of course, you get an F, then the cool feeling goes away really quick. But Michael's done. Daniel's done. Let's go ahead and take a look at these together. And I'll kind of talk through what my brain is doing here. I'm seeing 25 and 15 to get a 40. I'm seeing the 34 and 46 to get an 80. So I got 40 and 80 gives 120. How many got 120? All right. On the next one, I'm saving that 7 for last. I see the 2 times 5 to get 10. Times 3, 30. Times 7, 210. Or maybe the 10 and then the 3 and 7 gives 21. 10 times 21, 210. Would also be pretty easy. How many got 210? All right. Look at the next one. Definitely knocking out the 7 with the 21. This is where I might make a little mark with my pen or pencil. I might knock out the 7 and 21 and write a 3. Now I've got 2 times 4 times 2 times 3. I'll do 2 times 4 is 8. 2 times 3 is 6. 8 and 6 gives 48. How many got 48? Questions on that? Again, knock out that denominator 7 with any one of those numbers. Again, because any of those could be over 1. I'm too lazy to normally write the over 1 like I showed a minute ago, but because they are technically over 1, we could cancel. On the next one, I'm going to do the 5 times 100 is 500. 5 times 6, 30. That's 530. How many got 530 on number 10? All right. On the next one, 986, I need 14 more to get to 1,000. So if I steal the 14 from the 274, that gives me 260, and 1,000, which is 1,260. How many got 1,260? All right, questions on that one? And then on the last one, I'll probably take the half of 2 and just knock out the 2 and get a 1, which doesn't matter because it's a factor, right? And in addition, a 1 matters, and multiplication of 1 doesn't. So I'm going to knock that out, and then just move the decimal over 1 place this direction from your perspective and get 31.4. I got 31.4 on number 12. All right, questions on that? Again, it's just kind of talking through in real time what my brain does when I see those problems. And again, that's not just because it's in this section. That's what I'd be doing anytime, right? And so again, if you can see those kinds of things, just makes your life a little bit easier. Questions? Another practical thing of real life math, and I mentioned this a moment ago, you can go to the store or something and you're buying, you only have so much money and you got to buy these different things. This is more when you become an adult, Most of you, your mom is not sending you to the store to buy eggs and bread and, household needs. It's usually, candy and stuff you want to buy and video games or whatever, you waste your money on. But one day you're going to be the adult, right? You're going to have a certain amount of money. That's all you've got to spend till the end of the month. And you got to figure out, do I have enough to buy this stuff? And there are some people, you see them at the store. How many have seen this? You see the person, they're going through the checkout aisle, and they're like, can you take this off? Can you take this off? Can you take this off until the number comes down? I hate that. And then too, like you see this pack of raw chicken sitting there, like right on top of all the candy bars in the checkout aisle, because like, oh, let's take that off. And it just sits there because Walmart's too busy to take care of it. And you're like, well, don't buy candy from this place, who knows what sort of poisoning's in there. It'd be better if people knew how to estimate, right? Estimating is rounding off numbers. We kind of do this with division, don't we? We see 864 in the divisor, like, nope. Let's just picture a 9 there at the front. Same kind of thing can be used in practical math. Look at the page 100, that first paragraph. There at the bottom of that first paragraph it says, let's suppose 3 gallons of milk is what you needed to buy, and they cost $3.95. Well, I'm not thinking $3.95. I'm just saying that's about how much, class? $4, right? I'm buying 3 gallons. They're about $4. About how much is that?
Like
$12, right? Now, if there's tax, maybe add on an extra $1 worth of taxes. It'll be about $13, right? But again, that's dealing in nice, easy numbers. That's all we got time for. Okay, now the goal of estimation is to be as accurate as you can, as close as you can, while being easy. All right? really close to right and easy. So look, for instance, at that estimation box. The problem is 3,520 minus 1,985. Now, one way you could estimate, say, well, let's just round it up to 4,000 minus 2,000 is 2,000. Well, that was easy, wasn't it? But it's not really close to accurate. Look at example C. Well, that's about 3,500, and we could subtract, 1,990, but that's not easy, is it? Do you see how C is still kind of annoying? Whereas letter B, let's say about 3,500 minus about 2,000 is about 1,500. Letter B is pretty close to accurate and easy at the same time. That's the goal of estimation. Make it sense? Shake or rattle? You awake, Glenn? No? Okay. Evie, you in there? Hi, Evie. It's Monday. They just took a science exam. Their brains are fried. So that's what we're shooting for, right? So look at the next example problem. Let's suppose you want to buy 6 baseballs at $3.67 each. By the way, I was shocked how much balls cost. For like PE softballs, like $4 or $5 a piece. And there are some you could spend like literally like $12 on a single ball. I'm like, no. So I find the cheapest ones I can because it's just PE anyway. But I'm like, man, they're expensive. So $3.67 each for a baseball, buying 6 of them. All right, now, tell you what I might do. 367 to me says 3 2/3. 0.67 is really close to 2/3. I'm like, okay, in my head, I can do the whole 11/3. I'm seeing the 6 over 1. I'm canceling the 6 and the 3 to get a 2. I'm saying $22. Okay, so I could do that in my head, or I could be like, you're going to pay tax anyway, right? So let's just say $4, right? And there's 6 of them, $24. That way you don't have to worry about the tax later. You kind of factor it in. Usually it's better to overestimate anyway, because that way, let's say you're estimating as you're going along, you're like, all right, the milk is, $3.20 a gallon. Well, let's just say that's about $3, right? $3.20 is pretty close to 3. And let's say a loaf of bread's $1.80. We'll call that $2. And let's say a bottle of orange juice is, $2.70. $3. And let's say you also want Oreo cookies because you have to have some fun in your life. And if you buy only healthy stuff, that's no fun. So Oreo cookies are like, $1.37. Call it $1. And then probably need to round up for tax. So if we just add this together, it's 9. So I'm like, another $1 or $2 for tax, somewhere in the 10 or 11 range, right? And not that tax is always just $1 or $2, but you get the idea. So overestimate, if you'll underline that statement, an overestimate is better when a shopper needs to know if he has enough money. Because you'd be like, I only got $10. Well, $9, I didn't overestimate yet, right? Some of those numbers I kind of rounded down on. So when in doubt, maybe better to round up. But I figure I'm going to round some up, some down. It's all going to come out in the wash, and I'll add a few bucks for tax. But an overestimate is the safer bet. Look at the next examples at the top of page 101. Shopper's buying 5 books for $17.88 each. By the time you're done with tax, the books are going to cost about how much, class?
About $18.
By the time you pay tax, maybe closer to 20.
Yeah.
So I'd round it up to 20 and say 5 books, $20. That's going to be about how much?
$100.
About $100, right? It's not going to be quite that much, right? I've overestimated, but it'll be about that. Now, again, they're not accounting for tax. Plus, to me, 20 times 5, a whole lot easier than 18 times 5. You with me? Okay, so I'm saying it's going to be about $100. They're saying it'll be about $90. But again, by the time they pay tax, it'll be more than 90 anyway. So I still win. Actually, the government wins. The government takes the tax. But you get the idea of rounding. Look at the next one. 4 bags of mulch for $2.61. 2 pots for $9.97.
That's cheap.
I don't know. I don't buy mulch much. Now again, they're rounding down to $2.50 on the mulch. But I'm like, you got to pay tax on that mulch, right? I'm just going to make it $3, right? And so 4 bags, $3. How much is that?
12.
$12, okay? 2 pots, I'm just going to go right on par here. $9.97 is basically 10. I'm not going to make that any harder. 2 pots, $10, that's 20. So we had 4 times 3 was 12. We got 20 more. That's about $32. And maybe there's still a little tax ain't accounted for, 33, 34. As long as I got $35, I'm okay. Make sense? And that's practical, real life, everyday math. Now, they kind of came out on the short end because they rounded down. I'm like, they didn't even account it for tax yet, which if you live in Alabama is almost 10% tax now. Georgia's at 8, but yeah, Alabama's nuts. But their property tax is a lot cheaper. So you live in Alabama and you go across the river and do your shopping in Georgia. Or if you live in California, Rocky, I'm sorry, it's just your taxes are insane. But anyway, Bless you. Hey, come move to Georgia. You didn't have to watch on video. You can be in my classroom. How awesome would that be? All right, talk to your parents about that. Anyway, turn the page. Turn the page, page 102. And let's talk through which of these is the best estimate to use. Now again, best means it's easiest while still being somewhat accurate. So we're going to cross out the one that's just hard, okay? So number 13, first, second, or third, which one is just plain hard? The second one's obnoxious, isn't it? So cross out the second one. We definitely ain't doing that one. Now, of the two that are left, both of them are going to be pretty easy math, right? But which one's going to be the closest one? The first one's going to be closest, and we could do it in our head. What do you get if you add those together? 8,700, right? 8,700. That's going to be pretty close to right anyway, right? Look at number 14. Which one is just obnoxious still?
Middle. Well, no, big one on the far right.
The last one, right? Number 3, the third one, that's just obnoxious. Okay, that's almost no better than doing the regular subtraction problem. Now, I'll be honest, I'm really liking that first one. I'm liking the 11, but it's actually still not hard to do the middle one, right? Yeah. 17.8 minus 7.4, we could do in our head
10.4.
10.4, right? That's not that hard, and it's going to be a lot closer to accurate, isn't it? So that's probably the best one, is that middle one on number 14. Now about number 15, which one are we crossing out, Glenn?
Crossing out,
That first one's still annoying, isn't it? It's multiplication, so I'm not feeling the first one. But of the two that are easy, one of them is really pretty far off. Which one's going to be pretty far off for the answer, Aubrey?
The middle one.
The middle one. I mean, that's really easy, right? You got 12,000 with 2 more zeros, like what, 1,200,000?
Yeah.
We could do it in our head easily, but it's going to be pretty far off because we really rounded down on that first number. Probably the better one, or best one, class, would be the last one. Now, again, I'm really not going to multiply 2,400 times 600. I'm just going to multiply what, class?
24 times 6.
24 times 6. And how many zeros do I stick on the end?
4.
4. I've got 2 from each of them, so that's a total of 4 zeros.
144.
And that's a 144, so 1,440,000 is going to be really close to accurate. And it wasn't that hard to do either in my head or a quick thing on paper. Maybe we could have done it in our head. Look at number 16. Which one are we crossing out? Michael?
The first one.
I don't think the first one's bad at all. That first one seems pretty easy to me.
The second one.
The second one looks pretty annoying. So I'm definitely crossing out that second one because no. Now the two that are left, both cases I can knock off the trailing zeros, right?
Yeah.
So it's either 40 divided by 5 or 45 divided by 5, which is either 8 or 9, right? Which is more accurate? Class? The last one, right? Because 450 is going to be closer to the 438. So probably my answer is going to be about 9-ish, right? Again, 450 divided by 50, knock off the trailing zeros. It's really 45 divided by 5. 9 is about what my answer is going to be. Do we see how to estimate effectively and efficiently? All right, so let's look at the next page now. Let's take a look at some problems here. Number 21, go ahead and read that problem for us if you would, Danielle.
Size electric bill is $39.47. This month the bill is $32.55.
All right, so let's round some numbers off here, right? We're going to have to do what here in just a second, class? Subtract, right? And so we're going to subtract. And 39.47, what's that pretty close to, anybody?
39.50.
I'm thinking kind of the 39.50 only because, look at the next number. What's that pretty close to?
33.
32.50. Since they're both really close to the 50s are going to just knock off anyway, right?
$6.
So basically,
$6.
$7, right? It's about $7 difference because the cents are so close to 50 in both directions. Kind of ignore that. It's really 39 minus 32 because you're knocking off the 50 cents. So I'd say about $7 is the difference. If we were to actually subtract them, we would end up getting $6.92. I mean, we're within 8 cents. That's a pretty good estimate. Now, if you bump it, if you round it to like 39 and 33, you're getting 6. That's almost $1 off, right? By going to the 50s, which knock each other out anyway, getting pretty close. How about number 23? Read that for us, Michael.
Ben bought 12 pencils for 29 cents each and 4 gel pens for $1.24 each. What was the total cost?
All right, now that 29 cents, I can make that a nice easy number.
30.
30 cents, right? Because I can do the 30, 3 with a 0 at the end, times 12. Well, what's 3 times 12? 36. Stick the 0 on the end. 360, right? We'll put your decimal back in. So that's 360. And then we got 4 gel pens for $1.24 each. Now, because you're multiplying by a 4, if you were to make that $1.25 each, right? Because 4 times the 25 cents is $1, and you got the 4 times the 1 is also $4. So you got $4 plus $1 makes about $5, and that's really easy to add. So we're about 860. That's how I would do it. The actual cost, if you were to actually dig out a calculator and do it, which we won't because we're lazy, would be $8.44. And I'm less than 20 cents off. That's pretty close, right? So, you know, easy stuff there. How about number 25? Read that for us, Hayden.
Marty bought 19.6 gallons of gasoline for $2.87 per gallon. What was the total cost around the actual cost? It's about right now.
Yeah, pretty much. 287 is a little cheaper than I've seen lately. I've seen 289 as my cheapest lately. And the 19.6 gallons, let's make that 20 gallons-ish. And the 287 is pretty close to $3. So 20 gallons, $3. Now, I know I'm overestimating here, right? But still, I know it's going to be about $60. If you were to actually multiply, it's $56.25, so I'm a few dollars off. But again, an overestimate is safe, right? So not a problem there. Whereas here, the 860 was a little bit of an overestimate, but again, you're going to pay almost $1 in taxes. So you know, maybe should have rounded up a little bit more there. Yes, ma'am.
Isn't gas like $3.19?
Well, it depends on the kind you're buying. Like if you're buying the premium, it'll be a little more than that. If you're buying the mid-grade, but like the cheap gas, I've seen $2.99, $2.89, $2.91, $2.96.
That's so expensive.
Yeah, which you know.
Lowest I've seen is like
And you know, Rocky and Evan are like, really? I don't know what it is out there. You'll have to email me what your gas prices are over there. But I'm guessing, I don't know, 360 maybe? Just hazarding a guess, knowing California inflation.
In Florida, it's like $3.80.
Really? I guess, well, certain parts of Florida,
Well,
right?
yeah,
Big
yeah.
city, that kind of thing. They live outside Sacramento, so probably be pretty expensive there. Number 27. No, I'm going to have you work a few of these on your own. 22, 24, 26. Again, just do the estimate. If you're at home and have a calculator, you can dig that out and find the actual number yourself. I guess if you finish early, you can start figuring actual numbers, but we're going to be lazy in here. I want you to estimate the costs of these things using nice, easy, rounded numbers, but as accurate as you can be as well. Several people finishing up in here. And again, that's the goal, right? To be really quick. The whole point is get your math over with so you can move on to doing fun things like, you know, watching football. Unless you're an Alabama fan, then watching football may or may not be fun.
They smoked Texas A&M.
They lost to Texas A&M.
They lost. They got smoked by Texas.
I don't know if that's a guy got smoked. They got beat, but it wasn't like a getting beat down like what Alabama does to most teams. So.
Yeah.
Alabama hasn't had to be on the receiving end of one of those for quite a while.
And then Georgia beat Auburn. Wow.
That's actually really shocking.
All right, well, let's go and take a look at these. Rose bought 14 notebooks for $27.72. What was the cost of each notebook? What are we going to have to do here, class? Divide. And I am not dividing 27.72 by 14. Let's bump that up to maybe 28 divided by 14 comes out evenly to $2. And frankly, if you were to use a calculator figure, it's $1.98. Like, you're not that far off of the $2 anyway. How many had $2 as your estimate? Questions? Look at the next one. Local grocery store bought 8 crates of oranges at $24.78 each. What was the total cost? What are we going to have to do here? Multiply. And I'm going to bump that $24.78 to maybe $25. Now, I know this, that 25, 50, 75, 100, right? So if every 4 gives me 100, I've got 8. That's 2 sets of 4, so that's going to be 200. And again, the actual number, $198.24. $200, you're less than $2 off. So that's a really good estimate. How many had $200 as your estimate? Good. Well, the next one, bouquet of roses costs $23.56. A bouquet of tulips costs $17.86. What's the difference? Well, they're not both right around that 50 mark, right? So I'm just going to bump it up to whole numbers. Call the bouquet of roses 24. Call the bouquet of tulips 18. 24 minus 18. About $6. You're about 30 cents off. The actual number is $5.70, but close enough. $6 difference. How many had $6 difference? Questions?
So on 24, what would have been like the actual, not estimate?
The actual number was $198.24. So our estimate was $200. That was really close, right? So questions? Look at number 27. 5-pound bag of coffee costs $42.48. So what's the cost of 1 pound? What are we going to have to do here, class? Divide by 5. Now here's what I'm going to do here. $42.48 is kind of in no man's land, right? It's not quite big enough to bump up to 45, but it's also too big to bump down to 40. So I'm going to do both. If it's 5 pounds, how much is it for a pound if it were 40? 8, but 45 would be, so I'd split the difference between 8 and 9 and say $8.50. If you actually were to work it out, it's actually exactly $8.50. How about that? So, how's that work out? Can't be $8.50. Oh, if you round to the nearest cent. Okay, it rounds to, it's like, there's no way that works out evenly. But so it rounds to $8.50 anyway. So do you see I just kind of split the gap between them? Sometimes that's a helpful estimate method as well. Number 28, Thompsons pay $869 for their house payment, $383 for their car payment. What is the total payment amount? Again, let's round off the $869 to say 900 and the $383 to 400, 900, 400, 1,300, $1,300. Close enough. Actual payment, $1,252. But again, if you overestimate for your budget, then you have a little money left over at the end of the month. You're only $48 off. Speaking of 48, a box of 48 crayons costs $2.92. Box of 48 markers costs $19.73. I go with the crayons; they're cheaper, and they don't leave the permanent. Anyway, what's the difference? $2.92 is basically 1973 is basically 20. So basically $17 difference. Actual difference $16.81. So 19 cents off, not bad at all. Number 30, Amber bought 62 buttons from the store for 16 cents each. We could do 20, but if we're going to bump one number up, let's bump the other number down. Okay, so let's round up to 20 cents, but let's round down to how many buttons? 60. So 60 by 20, 1,200, but it's 1,200 cents, so that's 12 bucks. Okay. Now that's pretty far off because the actual cost, if you were to multiply, is $9.92. Okay, maybe it would have been better to go down to 15 cents. I don't know. But then we're underestimating if we also round down to 60, which is an easier number to work with as well. So, hey, better to overestimate than underestimate, right?
Wait, what was the answer?
The actual number is $9.92. I'm kind of estimating to 12 bucks.
Because if we would have did the 15 times 60, it would have been $9. So we would.
Right, we'd be underestimating now, and better to account for the tax and stuff like that. All right, anyway, this stuff, again, largely not tested, quizzed, but good practical, right? Practical, everyday, how you're actually going to do math most of your life, because you're not actually going to get on a piece of paper and be adding, subtracting, multiplying, dividing. And most people don't even want to pull out their phone calculator and do the math that way. They just want to do quick stuff in their head if they're capable. Questions? All right, your homework for this evening is to do page 103 in the homework section. 1 through 3 and 8 through 11. Page 103 in the homework section, 1 through 3 and 8. Hold on, and 8 through 11. And on page 108, you thought I was giving you 7 problems for homework? What do you think this is? All right, page 108, do the review 61 to 68. And on page 108, do the review 61 to 68. Page 103, homework 1 through 3 and 8 through 11. And page 108, review 61 to 68. Have a wonderful rest of your day.